This is lesson 6.2, and in this lesson you're going to be solving systems by substitution. Remember, a system is just a set of linear equations that have the same variables. And you learned that, on the last lesson, you learned that when you solve a system, really what you're looking for is a set of coordinates, an x and a y, where the two lines will intersect. On today's lesson, though, you're not going to be graphing anything, you're just going to be substituting. So for those who don't like graphing as much, this is a great way to do the same thing using a different method. Make sure you have a notebook, your ruler, and a pencil ready to go so that we can get started. Here's your learning target, and that is to solve systems of equations by using the substitution method. Remember to set up your Cornell notepaper. Put up in the upper left hand corner what lesson it is. This is substitution. Your essential question, how do you, if you've got a more creative way to write the essential question, go for it, but here is the learning target. You can hit the pause button, get it all set up, and then when you're ready, hit resume. Okay. Before we get started with what I'm going to teach you, I just wanted to do a little review. So at this point, just sit back and relax and watch. You don't have to write this down. I just want you to pay attention to how I remind you how you substitute. So here's an expression, 2x plus 1. It's not an equation. It doesn't have an equal sign, just an expression. But you can evaluate this expression when you let the variable x equal 4. And when you let a variable equal a value, the way you figure out what the expression equals is you substitute. You take this value of 4 and you replace the letter x with that. So you substitute the letter x with the value 4, and then you simplify. 2 times 4 is 8. 8 plus 1 is 9. So the value of the value of 2x plus 1 when x equals 4 is 9. That's an example of how you use substitution. Now if I were to take this expression and make it an equation like I have in this second part, 2x plus 1 equals y, now it's an equation, I can still use the substitution method, and I can still substitute the value 4 in place of the letter x, and when I do that I get 2. Every time I replace a letter with a value, I'm going to put it in parentheses. Plus 1 equals y. 2 times 4 is 8. 8 plus 1 is 9. Now instead of just getting a numeric value, now I have an equation that says y equals 9. Y equals 9 when x equals 4. And if I have an x and a y, what I really have is a set of coordinates. X is 4, y is 9. That's what you're going to be doing today in lesson 6.1. So here we go. Remember to copy these problems in your Cornell notes. So start by writing down problem 1 and copy the linear system. You can pause and get that written down and then resume when you're ready. Okay, the equation y equals 3x is one linear equation, and the equation x plus y equals negative 32 is another linear equation. In the last lesson you learned that if you graph them, they'll intersect, and that point of intersection is the solution. What we're going to do is come up with a solution that is an x and a y, but we're not going to graph it. Here's how it works. This first equation says y equals. What does y equal? It equals 3x. Now a whole bunch of people always get hung up on the fact that there's a variable in there, but just try to imagine that it's just a 3. So what we're going to do is we're going to take this second equation, x plus y equals negative 32, and we're going to substitute. And what we're going to substitute is what y equals. So generally what I do is I circle what y equals, and then I draw an arrow down to the letter y. That tells me I'm going to put the 3x in place of the y. So this equation, instead of x plus y, becomes x plus, in place of y, I'm going to put 3x. All I did was substitute what y equals with the value 3x. Now what good does that do us? Well, now we have an equation that just has x's in the equation, and so we can add them together. 1x plus 3x is 4x. And we can go a step further and solve this equation for what x equals by dividing both sides by 4. Negative 32 divided by 4 is negative 8. So by substituting, I've figured out the value of the x coordinate. That's negative 8. But as you can see, that's only half of our solution. We have to figure out what the y coordinate is. Well, if we know what the x coordinate is, and we have an equation that says y equals, then we can substitute for a second time. Y equals 3 times x. Y equals 3 times x equals negative 8. Substitute the value of x, which is negative 8. And we can figure out what y equals. 3 times negative 8 is negative 24. And that's the second coordinate, negative 24. And that's our solution. So I know the first time that I ever saw this, it was very foreign and it was not very easy to understand at first. So if you need to, you can back up the video and watch it again and try to process that. But I'm going to go on to problem 2 and show you a different example. Now we start with a linear system again. Two equations, two linear equations, both with an x and a y. And when we have a linear system, what we want to do is we want to find an equation that says that either x or y equals something. Y equals something or x equals something. Unfortunately, in both of these equations, we don't have that. Neither one of these equations says y equals or x equals. So we're going to have to do a little work. And what you're looking for in each of these equations is a single variable. If I look here, this is 4x. That's not a single variable, that's 4x. This is 3y. That's not a single variable, that's 3y. This is 3x, not a single variable. But here we have a single variable in just having y. So what that tells me is the second equation is the equation that I want to look at first. So I write out 18 equals 3x plus y. What I want it to say is y equals something. In other words, I want to solve for y. Well, in this equation, y plus 3x equals 18, I can solve for y by getting rid of the 3x. And the way that I get rid of this 3x, since it's being added to the y, is to subtract 3x from both sides. Once I've done that, the 3x's on the right-hand side go away, and I am left with 18 minus 3x equals y. Now one of my equations says y equals, y has a value, I can begin the substitution. So all I've done is taken this equation and rewrite it like this. So this one of my equations is no longer going to be used, just the first one and the new one. So notice that I'm rewriting it with the new equation. This is my linear system now. What does y equal in this equation? Well, y equals all of this. So I circle it. I would really encourage you to do the same thing. Circle what the y equals or circle what the x equals. Where will I put this value? Well, when you use the substitution system or the substitution method, you replace the letter y with the value. So I'm going to put this in place of the letter y in the second equation. Stay with me. So if I substitute the letter y in the second equation, what I end up with is 4x equals 3 times, anytime I replace a letter with a value, I'm going to put it in parentheses, so I get 18 minus 3x minus 2. Okay, now I'm going to distribute the 3. I have one equation that has just x's in it. 3 times 18 is 54, and 3 times minus 3x is minus 9x, and then a minus 2. Now if I'm going too fast for you, feel free to pause at any point, get caught up, look back through the notes, figure out what I'm doing, rewind it, watch it again. Do what you need to do to make sure that you're not lost by the time I get to the end of the problem, but that you're following along and understanding. Okay, 54 minus 2 is 52 minus 9x, and that's equal to 4x. I'm solving for x, so I'm going to add 9x to both sides. The 9x's go away. 4x plus 9x is 13x equals 52. And my last step is to divide both sides by 13. And when I do, I get x equals 4. Whew. Now, at this point, you're probably thinking, whew, that's a good problem, I'm done. Well, you're done with half of it. What you figured out is the x-coordinate. So the x-coordinate is 4, but to get a solution, you need an x and a y. So, in each of these substitution problems, it should always work out that once you get one, finding the second one is fairly simple, because you should have an equation that already says y equals something. If I want to figure out what y equals, I'm going to use the equation y equals. So 18 minus 3x is what y equals. Now I can take the value 4 and substitute that in place of the letter x in this equation. 18 minus 3 times 4 equals y. All I did was take the 4 and put it in place of the x right there. 3 times 4 is 12. 18 minus 12 is 6. So the entire solution for this linear system is 4, 6. And that's it. So if you're a person who doesn't like graphing, this is a method you can choose to use instead. Okay, what lesson would be complete without a story problem? Here's problem 3, which says a snack bar sells 2 sizes of snack packs. A large snack pack is $5. A small snack pack is $3. In one day, the snack bar sold 60 snack packs for a total of $220. How many small snack packs did the snack bar sell? Now, you may want to take a break here and come back and watch this later if you were confused with problem 1 and problem 2. Because problem 3 really involves understanding completely how the substitution method works. So if you need to take a break, hit the pause button and come back. But here we go. What you have to realize in story problems like this is, in general, you're going to have 2 types of equations. You're going to have a quantity equation and a value equation. And the quantity equation is just that. It's how many. It's the quantity. And the value equation is the value. It's what each is worth. So when you start a problem like this, you first have to define what it is you're talking about. And in this case, 2 sizes of snack packs, large and small. So all I'm going to do is define what my x and my y will equal. X will be the number of small snack packs, and y will be the number of large snack packs. Okay, hopefully you're with me. So we're going to start by writing a quantity equation. And what I normally do is just write a Q to remind me that I'm writing a quantity equation. In this problem, the quantity of snack packs sold is right here, 60. Now what you're trying to figure out is how many of the 60 are large and how many are small. Well, you don't really know yet, so all you can say is some small snack packs, that's X, were sold, plus some large snack packs, that's Y. When I add those together, I get a total of 60. That's my quantity equation. The value equation takes into consideration what the price for each of those snack packs is. So I'm going to write a value equation, and I just write a V to remind me that I'm writing a value equation. The price of a large snack pack is $5 and the price of a small snack pack is $3. So if I sell some number of small snack packs for $3 each, that looks like this. $3 times the number of small snack packs. Plus, if I sell some number of large snack packs, they're $5 each, so it's $5 times the number of large snack packs. Well, I get so much money for the small and so much money for the large, and when I add up all the money amounts, my total is going to equal $220 right here in the problem. Quantity and value. So now what I have is a system, a linear system. And what the question asks is, how many small snack packs did they sell? I have to figure out where these two lines intersect, where these two equations intersect. And I can do that using the substitution method. So I'm noticing that the first equation has a single variable x and a single variable y. I'm going to take this equation and transform it to make it look like this. Subtract x from both sides. I get y equals 60 minus x. And now I have a value of what y equals. It's 60 minus x. Using the substitution method, I can put this value in place of y in the second equation. Here we go. 3x plus 5 times whatever y equals, which is 60 minus x. If I use the distributive property, I get 5 times 60 is 300 minus 5 times x. And don't forget the 3x out front. 3x minus 5x is negative 2x plus 300. Now at this point it might start to look like it's going to be wrong, but it's not. Keep going. Subtract 300 from both sides. You get negative 2x equals negative 80. The last step is to divide by 2 or negative 2, and you end up with x equals 40. Now what does the letter x represent? This is why you define your variables in the beginning so you don't get confused. X is the number of small snack packs. And what does the question ask for? How many small snack packs? So the answer is 40 small snack packs. Now that's just the x coordinate. If I wanted to know the y coordinate, it's as easy as looking back at the first equation, x plus y equals 60. If x is 40 and I need a total of 60, the y must be equal to 20. 40 plus 20 is 60. So even though the problem doesn't ask for how many large snack packs are sold, you know 20 large snack packs are sold. Whew, that's exhausting. Okay. I'm including a part B for this problem for you to try on your own, but I'm not going to take the time to go over it in this video. We'll do that in class. So if you want to write the problem down or pause the video and give it a shot and come to class with an answer, we can look at that in class when you come back. There's just one last problem, problem 4, and if you recall in the first lesson, 6.1, there were situations where the lines never intersected when they were parallel, and there were situations where the lines were the exact same line and they always intersected where there was infinite solutions. That can also happen when you're using the substitution method. You just have to know how to recognize it. So here's what it might look like. Again, write down these equations. X in this problem is equal to negative 2y plus 4. So I'm going to replace the letter x in the second equation with that value. And I get 3.5 times, in place of x I write negative 2y plus 4, plus 7y equals 14. If I distribute, negative 2 times 3.5 is negative 7y, and 3.5 times 4 is 14, plus 7y equals 14. Now if I've lost you on the distributive property and multiplying and doing that too quickly, all you really need to see now is that negative 7y when added to 7y gives you 0, and what's left is 14 equals 14. And we've looked at this recently and reviewed it. What does it mean when 14 equals 14 and there are no variables left in the equation? Well, it's either no solution or infinite solutions. But because these are identical, this is an infinite solution. Okay, another part of this problem, part B. Here's another set of linear equations, a linear system. In this problem, y equals 3x minus 11. I'm going to put that value in place of y in the second equation. So I'm going to replace this y with 3x minus 11. Minus 3x equals negative 13. And just like the last problem, you'll notice the 3x and the negative 3x or minus 3x cancel each other out, and what's left is negative 11 equals negative 13. And just like part A, the variables go away or drop out, but what you're left with is an equation where negative 11 equals negative 13, and that's not true, so that's no solution. Okay. I realize that this is a very complicated lesson and there's a lot of algebra in it, and if you struggled with some of the distributive property or solving equations, this can be very intimidating. But I'd encourage you that if you have gone through these notes and are still a little bit lost, it might be helpful to go back and watch it one more time and then come to class tomorrow with some good questions. So as you go back through your notes, put question marks where you get a little confused, make sure you go back and you add questions, and that you finish up these notes as best you possibly can by writing a summary. So if you're willing, or excuse me, if you're wanting to get a head start, this is your assignment. At least take a look at it by opening your book and checking out this lesson, and then be ready when you come to class.